So let's move on to the Control and Performance tab. Item in the list. Okay, here we have in the editor panel we will have the information about the arrays. Okay, we will have the compact array, the Atacama compact array ACA, which is basically the 7-meter antennas. And here is some information about it, like the longest baseline, what is going to be the synthesized beam, shortest baseline, and the maximum recoverable scale for the most compact and most extended configuration of the 12-meter array. Okay, so we need to start filling up these cells here. So here is everything about the spatial resolution that we want for our project. So here we can choose between a single value of angular resolution. Here I remember that the source is each one of these beams is around 25 arcseconds. Now the source is super big. Okay. So, and then the spatial resolution I would like to have. Let's say, let's play. I would like to go for 5, no, 0.5 arcseconds. It's still fairly decent, not very high spatial resolution. Okay. And here, this is the largest angular structure in your source. So if you have, for example, extended sources, and they have different components, different like blobs, let's say, the largest one of them, that size, is the one that you want to image. So that is the size you will include here. Okay. This source, I know from other wavelengths that is this bright, but it has a lot of substructures. And let's assume that the largest superstructure that source has, and I want to map, is 10 times that, the 10 times the spatial resolution I want. Okay, and the side sensitivity I would like to get 5 millijansky per beam. If I am going to do continuum observations, this is the noise, this is the RMS that I want to have in the final product, in the final continuum map. This will be the noise I will like to have. Okay. If I am going to for spectral lines, this will be the RMS that I want in one of the channels of the cube that I am going to have. Okay. So let's keep it in 5 millijanskys. It's kind of shallow, but let's see. Okay, and then this bandwidth used for sensitivity is used in combination with the representative window that you choose in this spectral setup. Okay. Remember that in the spectral setup you had to select the representative window. In this case, we select the one that we are going to use for CO observations. So if we use in the correlator mode the entire bandwidth with a spectral resolution of 1.1 kilometers per 1.1 megahertz, and go here. So this is the number that is going to show up here. Okay. If I don't want to go for the representative window resolution, which is the default value here, but I want to go for not for the resolution but for the representative window bandwidth, so it will take into account this number. For example, if I change this and I go for 10 times better spectral resolution, around about, so remember that spectral resolution was 0.1 megahertz, and this is the number that is here. And if I take the bandwidth, you are going to see that this is the number that is going to show up here, basically. Okay, this is the entire bandwidth. So if I already have these numbers, let's see if this makes sense. And let's see how many days we need. Ah, look at that. This is not that bad. 34 minutes. I can use observations in two configurations in order to reach the goals I want for the resolutions I input. And this is a breakdown of pointing, so all information that will be included in the technical justification in order to detect, to see how much time you need. Okay, but this is for you basically. You need 2 pointings, one, and how many calibrators you need, calibration observations you need. This is overheads basically. But let's change some numbers here and see what happens. So if the largest angular structure in my source is of the size of the maximum recoverable scale, and these two numbers are around the same, not much happened. But I want better spatial resolution. Then something happened. Okay, the spatial resolution I want now is better, and now it is suggesting using the 7-meter array. Okay, so that is why the time increases, because now it is also estimating time on the. Notices that the time on the 12-meter array is around the same that it was showing before, right? Perhaps not. All right, but then this is how, and then you can, in here you can go for different options. Notice that this is always concerning the size or the frequency range that you will use to estimate the noise, the sensitivity. Okay, if you use a very wide spectral range, very wide bandwidth, to reach the same level, to reach a given level of sensitivity will take shorter than in a narrower bandwidth. Okay, so for example here you can go from the entire bandwidth to the resolution of that spectral window. Okay, you can use aggregate bandwidth. This is for continuous observations, for example, in being set up as we did here. For this window, we are using the bolded correlator mode here, which is this is the lowest spectral resolution we can have. And that is for continuous observations. And when you are going for continuous observations in this mode, in spectral mode, it will be the aggregate bandwidth will be the system will calculate it, and then it will be the total of non-overlapping one bandwidth that is free from line emission. Okay, that will be this number here. So notice that is 5 gigahertz. So that will take too short. What if the largest angular structure is twice the size of the the maximum recoverable scale? It doesn't suggest anything else more. Or insanely big. Increases a little bit, but not much. And here the time on the it also suggests to include time on the total power. Yeah. So this is what I was looking for. Okay. Including all the 3 arrays as a suggestion. Okay. From the system. All right. So this is how you play in the control and performance item of the list of the science goal. Now we move on to the technical justification. So in the technical justification, take into account that you need to fill up all of these cells here. You need to justify why is that you are requesting the imaging capabilities, the correlator configuration, and the sensitivity goals that you are looking for. Why is that? Okay, and not all the warnings are in red. So take into account this is a warning, and we need to get rid of it. And this is concerning the bandwidth that we are using to estimate the sensitivity. That is, yeah, it's too wide. Okay. If we go for the finest resolution or for the representative window spectral resolution, you see that the numbers now is different, and that the blue warning disappeared. Okay, so from here, in principle, we can take a look in how the proposal is looking. Take a look. Show a printable summary of the science goal. This is a summary of the science goal. You can go for any of them. So this is actually how the technical justification will look in your proposal. So this is the spectral setup, the correlator setup we choose for the spectral line, the tunings, the representative frequency. All of this information will always be placed at the end of the of the proposal. And each science goal will have a page for that. So you can save it. And you can generate a PDF of the whole proposal. You can display the project time summary. So it is suggesting two different configurations, combination of them with the ACA, the total power. Overall, it's taking a long time, okay? But it is just to show how to include all of them. So in the technical justification tab, we don't have any blue warnings already, okay? So we in principle have everything in place. Yeah, and then we can try to validate or we can first see if we have already attached one proposal. Let me just cross check that. If we have text here, yes. All right, so we can try to first generate a PDF of the whole proposal. Okay. So this will take some seconds. Just wait, put some name, save it, whatever you need, and look for it. Yeah, circulate. This one. So here we need to include the abstract, the breakdown of the time going to be here, estimated for the total power, for the 7-meter array, and for the 12-meter array. If you are going to do the same, basically, that is duplication, when your science goals are similar among them, or the system finds some science goals that are similar to other projects, for example. We need to read about that. When a duplication is a duplication. All right. Representative science goals, and then the text of the proposal that is attached at the proposal level. Okay. So this will be the text, the PDF of it. I'm sorry. Yeah, I was looking also for the information that is after the text. It's this one, which is the information we were just working on the spectral spatial setup, also on the calibration performance. Here we need to fill up these boxes. Otherwise, you will see what happens if you don't. If we go ahead like it is right now, we haven't included any information in these cells. These are the boxes I was referring to. Okay. If you don't know how to include things here, go for the technical justification here, and there are some subsections here that will help you. And source, the large angular structure, the sizes of the structures that you want to image in your source. All right, okay. So if we don't include information there, and we go straight for the validation, let's go what happened, let's see what happened. Let's bring up the feedback tab. Feedback tab, this was from a previous validation I did, but it is not going to be that gentle now. You see, there are errors. Abstract is not there. Sensitivity justification must be at least 50 characters. Also for the correlator setup and also for the imaging justification. And the suggestion is edit your abstract, edit the text in these boxes, okay? So I will follow the suggestion and include relevant data, relevant information in order to justify my project. And because this is just one example, I just want to do this, okay? Just to show you that those errors are going to go out. Let's see. Just validating again. The errors aren't there. Only the abstract, okay? But the abstract, you need to think about it and you need to come out with something very good. Not the time right now, but in any case, this is also valid for the abstract. So validate, and let's get that positive check. Not problem found. All right. So in principle, we could go to file and then submit the project. Okay. If you are ready with your project, go for it. Okay, and good luck.